and we are going to be talking with Amit today about operators. It is a topic that is super hot topic right now. It is something that I know lots of people are thinking about using or abusing or frustrated with or whatever you want to say around it. I'd love to hear while we're waiting for the rest of the crew to jump on in these last couple seconds. I'd love to hear if anyone is using operators in their workflow. If so, what are you using? How do you like them? Give us a bit of an update what the lay of the land looks like right now. And I think we can go ahead and get started.
Cool.
I am super excited, not only because you have a living wall in the background, but because operators are something that I know I have been wanting to create a series
Yeah.
around. So I am going to label this the first in the operator series. I don't have number 2
Nice.
lined up yet,
All
but we're
right.
just going to say that it's the first and trust that there will be someone else that comes forward and wants to
That's exciting.
talk about operators with us. You all can see on your screen, but Amit is working at Confluent. He's the group product manager. And today we're going to be talking about the Confluent operator and just a real broad overview of what is happening in the operator space, when you use them, what you use them for, and all that good stuff. So now I'm going to be stopping the screen share so that we can all get cozy. And Amit, I usually start these talks with a quick question about how you got into tech.
Cool. All right. Yeah, let's go into that one. That's a fun story. First of all, thanks for inviting me to this. I'm super excited for this conversation. I think it's gonna be a ton of fun.
Nice.
Yeah, so thanks again setting this up, setting up the whole community. This is pretty dope. So let me get into that question. It's a pretty I think it's a pretty cool story. So I came to California. I'm originally from Toronto, Canada. I came to California for grad school, and I was studying pure math, like the purest, most abstract, useless math that nobody's going to use in 100 years or more. And to make a little extra money, I picked up some tutoring on the side, and to kind of make a long story short, at some point I found myself tutoring uh, a guy who had his own tech company. So I started doing that, and that guy was the CEO of Pivotal, way before Pivotal was as big as it was. So that was
What? And you
Rob
were
Me,
tutoring
and
him in math?
yeah, I don't know actually the full backstory. I've always heard like weird urban legends stuff like that, but one of the urban legends I heard was that he had a son on the way, or he had a kid on the way, and he wanted to be able to teach his kid advanced math and calculus by the time he was 5 or 6, so he
No
could
way.
be the whatever he wanted to be. So
Uh,
yeah, when I the first time I went to go tutor Rob in his office, I didn't even know it was his company. So I walked in. I'm like, dude, you have your own corner office? Like that's pretty sweet. I don't see any other offices like that. He's like, yeah, this is my company. So,
no
anyways,
way.
he had these books of like advanced graduate math textbooks and stuff on his desk. And he's like, I'm trying to work my way up to there. I'm starting with proofs. I did math in college, but I'm trying to get back to this kind of graduate level and stuck on proofs. So that's how we started kind of working together, just tutoring. And then
Mm.
at some point, I wanted to get out of academia, get into something else. And so I was talking to him about getting into tech. And yeah, long story short, I ended up at Pivotal many years ago. Um, and yeah, I've been there for many years, and now I'm at Confluent. Been at Confluent for almost a year.
What an awesome story. What a
Yep.
random way to get into it too. I love it.
Yeah, very random. So no, yeah, I mean, I had obviously done some like coding in college, and uh, you know, my thinking was like, if I'm dealing with all this crazy abstract math where I spend a few weeks reading a paragraph until it clicks, then I'm sure I can figure out like Ruby on Rails and stuff
Yeah.
like that, which is what I started doing.
Sweet.
Yeah.
So, can you talk to us a bit about how the Kubernetes space has evolved and how you've seen it evolve in with respect to like Kafka and databases in general?
Yeah, sure. I think so when I was at Pivotal, one of the projects I was working on was our container scheduler. We were kind of rewriting the kind of container orchestration for Cloud Foundry, which is an open source platform as a service. I think most people are familiar with Cloud Foundry, but if you're not, you're probably familiar with Heroku. So you can kind of think of it as like an open source Heroku where enterprises could go kind of run it and deploy it themselves for their own internal, you know, tens of thousands of developers or whatever they have.
Mhm.
So we were working on kind of rebuilding, redesigning the whole container orchestration piece. And so Kubernetes, Docker came on the scene. Mesos was kind of already there. Kubernetes came on the scene. Um, and so, in the early days, there was all these things like what's going to win Mesos, Docker Swarm, Kubernetes, right? Um, I think clearly Kubernetes has won that space,
Yeah.
and it's gone from I think where it was initially, it really caught on to like the Docker wave, right? Docker was huge. That really I think improved a lot of people's lives in a tangible way, in a really like incremental way, right? They could see how it's like better from what they're doing now, and then Kubernetes was like a clear like advancement on top of that. Right
Mm.
now, I can have my Docker stuff deployed on many machines, and so that was, I think that was like the key value prop, like manage Docker containers on many machines, and it's got the Google, like uh, stamp of approval behind it. They can say, this is Google scale. You probably have the same problems Google does, even though that's not true. Use Kubernetes.
Yeah.
And so, yeah, I think it really caught on. It had a really good like grassroots community movement as well. The open source community blew up. But I think it was still, it was actually very hard to use it for lots of things. It was hard for higher
Mm.
level things, like higher level applications. It's too low level, and of course, like support for stateful workloads was not really there in the early days. So I
Mm.
think what we've seen now is, as it's grown, I think that value prop of like container orchestration and workload management is still there. Uh, but I think it's evolving to be kind of an ecosystem of like a consistent way to extend the Kubernetes APIs with higher level APIs, and the ecosystem around it, the ecosystem of people building monitoring solutions and logging solutions, data services on top. That's what really is creating this like network effect that's kind of making it so sticky, and like why that's I think a big reason why people are building operators and building Helm charts and that sort of thing.
Yeah.
So, as it pertains specifically to data, like you've seen, stateful sets, and we see, storage classes, dynamic provisioning, I think is awesome. It kind of makes that cloud native feel, the sort of like the feel that you get with Kubernetes automating your containers and automating management for you.
Mm.
You get that same sort of feel, with your persistent volumes as well. So I think the pieces are kind of coming along, and I think operators are where we are, current state in terms of how to actually manage those. We can go kind of another level deeper of like why operators as well.
Yeah. And that was kind of my next question, but maybe before we jump into that,
Yeah.
let's look at how you feel operators are like right now. Why do we have this need for them?
hmm Yeah. So um, the way I would think about it is, s- uh, so let's go back a little bit more in history again. At least from my perspective, this is kind of how I've seen things evolve. So one of the things I was doing at Pivotal, after working on this container scheduler stuff, uh, our orchestration system used etcd on the back end, very similar to Kubernetes. And uh, we had, I won't go into all the details, but at some point, the architecture of Cloud Foundry had two distinct etcd clusters and a console cluster. So we had three of these kind of raft based quorum systems for different kinds of essentially like ephemeral state management and service discovery.
Mm.
And our product at that time, so Cloud Foundry, was something that we would package and ship for customers to then install and self manage. So if you think about like your typical enterprise and you're saying, here's a bundle, it has two etcds plus console plus a container scheduler plus a routing tier, an identity tier, uh, and all these other things to make this complete, Heroku thing in a box. That's pretty complex. And for this to reach many customers, they're not going to have like 10 Silicon Valley, people with like 25 years experience that know all the sort of distributed system stuff and that full stack and be able to figure it out all themselves. It has to be kind of turnkey, right? That's the key.
Mm.
Like, how can you make these complex distributed systems turnkey, especially when this is just a small part of a much larger system? And so I took on responsibility for a few things. One was our kind of we were using a technology called Bosch, and I think Bosch was uh, uh, like a precursor in a lot of ways to like Kubernetes and operators. So we had the equivalent of like a operator for console and an operator for etcd. And the key challenges came across, like, it's easy enough to like run some software on some machines, right? Where it gets really hard is managing the like nitty gritty of the life cycle when these sort of like raft based systems, right?
Oh, yeah.
They're meant to do leader election, and if there's a network partition and then the partition heals, you expect the cluster to come back and self heal.
Mm.
So we would have customers say, okay, we're going to go deploy this across like three data centers, and we're going to just pull the power on one data center, and we're going to plug it back in, and your product better, keep working. And we also want to be able to rotate certificates all the time, and we want to be able to scale up and scale down and do all sorts of troubleshooting and all that sort of stuff. So when you look at like the full nitty gritty of the full life cycle of managing these complex distributed systems, and that has to be turnkey, uh, that's when things get tricky. So what we found was we were writing a lot of code. Let me give you like a concrete example, and I think this is a problem
Mm.
in Kubernetes today. Your workloads don't know if they're going away for good or they're just being like rolled, right?
Great
So
point.
if you have a cluster, and you're removing one of the nodes because you're scaling down, you might want it to behave differently than you may want it to kind of like share its data with its peers and like move the data off, versus if it's just going down because you're like updating the OS, you don't need to do that, right? Versus if you're just deleting the whole cluster, then you don't even need to bother with the like just like delete the thing. You don't need to bother
Mm-hmm.
orchestrating cluster membership and all that sort of stuff, or do any leader elections. Like, just it should just go away. um so nothing in the like Bosch, nothing gave us as like a Bosch release author or like a Bosch operator author the hook to know about these sorts of things happening in the life cycle. And so the way I'd kind of summarize that is distributed systems are hard, and uh, trying to provide a solution for managing certain kinds of distributed systems in a generic framework that's meant to work for everything, right? Like Bosch was meant to, or like
Mm-hmm.
Kubernetes is meant to,
Yeah.
is really hard, right? You get this, like, the specific needs of the software and the really kind of idiosyncratic needs of the software with the generic nature of the platform, right? So like Kubernetes has certain hooks, lifecycle hooks that you can kind of write scripts for. But if it doesn't give you everything you need, or you end up having to write, you know, a lot of logic, that's kind of where that's kind of why we have operators, right? Because I think a uh, to go from the generic structure that Kubernetes gives you to like the actual lifecycle needs of your software, that just requires a lot of code, I think, right? Because to make
Mhm.
that fit, and so that's why I think we have operators. I think the I think what's great about operators is it's this idea of like you as a vendor can actually package this code that orchestrates your thing uh, in in a way that still gives a kind of a consistent experience to the customer.
And I think that's interesting to talk about maybe like one step further along those lines of these operators. You're basically customizing
Hmm.
Kubernetes for
Hmm.
your product by
Yeah.
using this operator, right? And then going the next step and saying, all right, well, what about the end users? How much customization have you seen from them on the operators?
Hmm. Yeah. Yeah, that's always like a kind of a like a messy question, right?
Mm,
So I think to well to go back to the previous point for a second, right? I think you can give people just your raw binaries or your raw jar files, and they can customize whatever they want. They can do literally whatever they
mhm,
want with that. But then you're not helping them operate the thing. Um, you can provide them then instead like your own custom orchestration tool, but then that's a one-off like island tool that they have to learn, and it doesn't fit into the rest of their Kubernetes ecosystem. So I think the operators kind of uh, are the best of both worlds, where you're providing a lot of custom logic to operate the thing, but they're getting a Kubernetes kind of native experience as well. So it's something that they're
mm,
used to, something that a lot of their tooling kind of helps them with. Now to come to your question about like how much customization are you seeing? Yeah, that's a good question. I think there's kind of two ways to think about like where you might customize. One is in the images themselves, right? People um, taking your images and they may be modifying your software. Hopefully not, but they may be layering on other stuff, right? Maybe it's a bank and they require some like antivirus thing in all the images, so they're layering stuff on. Or we've seen customers who they require their images to be built off on top of some like blessed golden image within the organization. All
mhm.
images shall to be built on top of this image. So they're like, they want to rebuild all your images on top of their base image. And then there's of course like configuring the software and tuning all the parameters. So if you talk about something like Kafka, it has hundreds of different kind of server properties that you can configure. Um, and how much of that do you kind of pass through to the uh, how much do you allow the end user to like configure those things through versus like take an opinionated stance and kind of prevent them from doing that.
Hmm.
I think probably the more challenging aspect is that the last one I talked about, like the configuration. How much configuration do you let people pass through?
Yeah.
And I think I think for the most part, people, at least when they're getting started, they want something opinionated. Um, and they don't you should make it easy for them to not shoot themselves in the foot, and they don't necessarily need all the combinations of configurations. And in fact, with an operator, you can start to do intelligent things where you have validation webhooks and you can say like, oh, it looks like you said you want backups to go to S3 and you've given me GCP credentials JSON. That seems like you've made a mistake there.
Hmm.
So like you can start to do intelligent kind of validations there and say certain property combinations are just probably bad. But I think uh, the product that I worked on previously at Pivotal was very opinionated, and what we eventually saw with um, the more advanced customers is they were like, "Why don't you let me configure that one thing underneath? Like,
Yeah.
this is blocking me bringing on a more secure set of workloads into production." Uh, I'm smart now. I've been using your product for 4 years. Why are you blocking me from like configuring these low level things? So I think there's always this tension between like flexibility and kind of like um, guardrails.
Yeah. It's
Fundamentally, that's always there. And I think that where I'm kind of like my mind is at now is give people that pass through,
mm,
uh, provide some sort of like white box where if they must, like they can pass through configuration, because you can't predict the future. And what you don't want to be in the game of like your job as the team building the operator for customers is just, oh, they need this thing, this property, so you got
Yeah,
to
yeah.
expose that property so you can just pass it through to that thing. Like nobody wants to be in that game. So we'll see. This could be a mess. Like it could make things really complicated, but
Well, it's a
yeah,
fine
I think
line
it's
that
a very
you
fine
have
line.
to walk, right? Like you of this operator is supposed to make your life easy,
Hmm. Hmm.
and you if you end up configuring and customizing it to the max, then it's not doing much on making your life easier. So,
Yeah.
uh, my next question was around operators, and I know there was a great question in our Slack about operators and if they're like infrastructure as code. And you
Yeah.
had an awesome
Yeah.
answer on that. Can we try and recreate that magic
Let me
maybe?
try to recreate that magic. Yeah. All right. So I think the way, I think about that question is, I think there's a lot of these terms in our industry, infrastructure as code and DevOps and GitOps and all those sorts of things, which, uh, they easily go from like whatever the original intention was, trying to be captured in this like pithy 3-word thing, to some like completely different interpretation of it, where, um, you know you may be doing infrastructure that's technically code, but all the benefits of infrastructure as code is not really there, right? And I think a lot of these, you know cloud native infrastructure as code, all these things are, uh, they come with like practices and ways of doing things that's meant to make your life easier, where if you only just do the like what it says on paper of like, yes, my infrastructure is technically code, but then, you you don't update your infrastructure for like 6 months, then you're defeated, and then it defeats the purpose, right? So, let me give like one bullet that, was there, is kind of like the whole idea of code and software. It's called software because it's, you can change it, and what we can do with code is change it constantly, run it constantly. Whereas if it's a human process, that's toilsome. Like you can't just keep doing the same repetitive thing over and over again. You're going to make mistakes. It's going to take a lot longer.
Go
So
crazy.
you
Yeah.
go crazy, right? So, the whole idea of infrastructure as code is to think about all the infrastructure you need for your application or your suite of applications, your whole product portfolio, all the infrastructure you need, from the networking to the compute layers and data services and all that. Encapsulate the desired state for that in code, or maybe declarative codes like YAML. We can debate whether YAML is code or not, but make it so that it's something a machine can execute. It's something that a machine can inspect, and it's something that you can run like every minute. Who cares, right? Like just run it all the time. It should be idempotent, and when you make an incremental change, you should be able to, see the impact of that incremental change. If you have something like Terraform Plan and you're using a tool like Terraform, you can see what that's going to be, and then you can, if it's a dev environment, have that just go through. If it's a prod environment, maybe your build should stop and show you what that output was, and somebody clicks a button and says, yeah, push it to prod, right? But the idea is like the code is making the changes, uh, to your infrastructure, and it's all captured in code, so you get all the benefits of something being in code. Especially if you have it in Git, then you can see who made the change, why did they make the change, when did they make a change. You can control who has permissions to make changes. You can even go from staging to prod with like branch promotion. There's kind of like, patterns with Git that you can apply to, you know uh, kind of simulate, if you will, these processes that you have in your actual environments. So that, I think that's what, infrastructure as code is about. Is
Mm.
about letting code and machines, uh, do your infrastructure management, so that it can be done, continuously and toil free in kind of a low risk way. And operators, I think, are just a piece of that, right? So I think in your whole stack, you might have Terraform to set up your, your VPCs and your K8s clusters, let's say, and then you've got a bunch of, operators to, stamp down all your, let's call it like middleware or data tier infrastructure, stuff like
Yeah.
that. So you might be using a bunch of declarative, YAML, Kubernetes YAML to declare the kinds of Kafka clusters you want, and the operator will just make it so, right? So I think it goes together with like pipelines and things like operators, which automatically execute your desired state.
Hmm. Yeah, that makes sense. And I like the way that you break that down for us. So let's dive into the Confluent operator a little bit. And
Yeah,
can you give us a high level overview of what it does, what it doesn't do, what you can expect with it, and where
yeah,
that need came from?
yeah. Sure. Let's start with the like, why does it even exist? Confluent, the Confluent operator came from our own need internally at Confluent for Confluent Cloud. The way I kind of describe Confluent Cloud is, well, Confluent Cloud is a fully managed service that gives you Kafka plus a whole sort of ecosystem of things in and around Kafka and event streaming to kind of complete that event streaming platform picture. So Confluent has, for example, a schema registry. So it helps you can perform schema validation. So you can make sure that the data that's being produced into your Kafka topics conforms to a certain a certain schema. So you know that it's useful data. It hasn't been corrupted. That the applications on the other end can expect some sort of consistent format. So we've got things like a schema registry. We've got a GUI uh, that, for Kafka. We've got a REST proxy. So if you have any applications that you also want to kind of be able to leverage the data in Kafka, but there's simpler and restful. They don't want to speak the Kafka protocol. Like you can still kind of leverage that. And of course, we've got a big, rich Connect ecosystem. I think a big part of what Kafka is about is being this sort of like central nervous system for all the data in your in your organization. So that means maybe pulling data out of some legacy sources. You want to pull it into Kafka. You want to process it. You want to share it with multiple different applications on the back end, and then they may want to store snapshots of that data in a relational database. So some analytics like that the analytics team can run some queries on it. And maybe in the future, you could do the analytics right in Kafka. You may start to use things like KSQL DB and that sort of thing. But for whatever reason, maybe you want to put it out to S3 or some other
Mhm.
database. You can do that with this sort of Connect framework. So that's like in a nutshell the whole Confluent stack, or some of the key pieces of it. Confluent Cloud is a fully managed offering of that, and we offer Confluent Cloud on all the major cloud providers, so Amazon, Google, and Azure, and in dozens of different regions. And we needed a way to sanely manage all these Kafkas everywhere for these thousands of tens of thousands of users, whatever it might be. With their we need to our production environment is the production environment for like tens of thousands of other people. So we needed a really you know um, intelligent way to manage all these things. We couldn't be there like SSHing into servers and hand editing config files and like managing processes and checking under replicated partitions and all the like complexity of like the playbook you would run, the like 100-step playbook you would run to update a Kafka cluster. We needed that to be all automated. And so the operator is a kind of a natural fit. That's kind of where it came from. And then over the last kind of year or so, we've been kind of hammering it into kind of enterprise grade shape, to kind of fit our enterprise market, right? Like
Yeah.
our
Okay.
enterprises, uh, enterprises are under different constraints than the Silicon Valley, company like Confluent is. This I think will be like an interesting conversation for the community. I'm curious what kinds of things other people are seeing if they're building operators and they're selling them to enterprises. Big one we've seen is customers don't have load balancers on prem. The idea
Mm.
of a service, a Kubernetes service of type load balancer, usually isn't there on prem. So like, how do you get traffic into your applications, especially when it's not an HTTP application? Is kind of like kind of a bit of a mess right now. So there's some of those interesting challenges that I think come up when not even operator specific, but any Kubernetes sort of product that you're shipping to uh, enterprise customers, especially if they're on-prem and not in the public clouds.
Yeah, that's a really interesting one. I'm gonna in a few weeks at the end of September, actually, I'm gonna have somebody from Packet on here, and they're all bare metal. So I'll
Hmm.
ask them if they've been seeing that and how the people they've been seeing doing that, what enterprises are doing instead,
Hmm.
because that is a super interesting question. Now,
Yeah.
can you give us your thoughts on this idea of the managed services versus running your own, and maybe some use cases of each of these?
Yeah. Yeah. Sure. I think I'd say the managed service should be like the default, right? Like if you can use a managed service, you should. Um, I think all code is kind of tech debt, right? If you can even not write your own applications, like do that. So if you can use a managed service, I would say do that. I think there may be some cases where you need to run your own, right? So uh, just to kind of enumerate some, if you're kind of running at the edge, you're running your own, right? We don't have a managed service in your store. If you're air gapped, so uh, for highly uh, financial institutions, any sort of like certain types of government institutions or even like military institutions, they're going to be fully air gapped. Like you're literally not going to be able to. They will never be able to reach your managed service. They will not even be able to reach your docs website. So
Hmm.
um, anything that's completely air gapped is a clear case for kind of self hosting. I think another one can kind of be uh, you have to kind of look at the cost profile of uh, if you have like cheap hardware and that sort of thing, and you have a team that can easily manage stuff, then the cost of having a team managing software might be less than the cost of uh, the managed service. I think that's just always like a trade-off you have to make.
Yeah.
It might be that like at very large scales, unless you're getting like large discounts from cloud providers or something like that, it may make sense to kind of think about self-hosting. And then I think also like very very critical data that you don't want anybody to touch, or compliance regulations don't allow you to allow anyone else to touch that data. Like the rules say your data needs to stay in your data center. I think those are some of the like very clear use cases I would say for kind of self-hosting.
So you mentioned running stuff out on the edge, and I was wondering about like operators that are on the edge. Do they behave differently when it's on the edge versus in this centralized high performance environment? And I totally forgive you if this question is kind of out of left field and you can't really speak to it that much, but I kind of was talking with a friend earlier about this, and we were wondering about that. Do you see any differences, and if so, what?
um i I won't say I see any differences, but it might just be that I haven't seen them yet. um
Mm,
I think the like we talk about the edge, but I think the like edge environments actually have a lot of different profiles. So you could have an edge environment that is like a large factory for an auto manufacturer where they've got you know uh, pretty heavy hardware out there, right? So it's technically the edge, but it's definitely powerful enough to run your system, right? It may be disconnected from the internet. You may not have a lot of network connectivity, but you typically don't need that. Like if you have your image registry also there at the edge, and you pull in your images to your edge registry, then hopefully your whole environment is pretty self-contained, right? And your applications don't need to reach out to the internet for too much. Um, for, so there's that kind of edge environment, and there's kind of like the edge environment that like maybe you've seen Chick-fil-A blog about, or like, something that's got to
Mm,
fit in someone's backpack, or it's on some like Raspberry Pis,
yeah.
sitting under a shelf somewhere. Um, so for those environments, I think I wouldn't think this is like an operator specific question. I think the question would be like, is Kubernetes and all that overhead uh, something that kind of like can fit in these edge environments? I
Yeah, that
think the
makes
answer
sense.
is yes. The reason I say that is, again, the previous product that I worked on, uh, we were thinking about how to deal with that on the edge, the cloud foundry thing. Um, and Pivotal also had a Kubernetes offering. And I think what we saw from customers, and we saw from even not our customers who were just doing this organically themselves, is they were putting Kubernetes out at the edge. I think it was just lighter weight. Like it's maybe funny to say that Kubernetes is lightweight, but depends what you're comparing it to. But I think relatively, and maybe especially with projects like K3s, like you can find small, lightweight ways to deploy Kates at the edge. And then, if you're deploying Kafka, uh, as long as you're not trying to deploy like hundreds of gigs worth of memory of Kafka brokers, but if it's a small deployment, then yeah, I think you can do it.
So I want to ask a question from Alok. He's asking in the chat if it's
Yeah,
possible to deploy Confluent Operator to Red Hat OpenShift.
yeah, yeah. I did it yesterday.
Nice.
Uh,
There you go.
yeah, it's so with the Confluent operator, we're taking the stance of leaning into the CNCF conformance. Cloud Native Computing Foundation, which is the governing body behind Kubernetes, has this concept of conformance, where any uh, any vendor or any open source project that wants to uh, claim itself to be some sort of distribution of Kubernetes or a managed hosted offering of Kubernetes can run sort of a set of tests that prove that it's this is a conformant distribution of Kubernetes 1.16 or conformant version of Kubernetes 1.17, and then they just maintain a big old spreadsheet, and you can just look at that. And so the stance we're taking is there's hundreds of these vendors, right? And
Totally.
we are not going to be our goal is to give customers and users like freedom of choice. So we're not there picking winners in the like Kate's vendor marketplace. Uh, we want to work with any conformant Kubernetes distro, and we'll let that whole picking winners, leave that to the kind of the rest of the community. I think honestly, like I this is similar to and different from a place we've all been before, which is OpenStack, right?
Mm,
Um, OpenStack OpenStack was kind of similar in that uh, it's completely open source. It came out. It's got these like versions that it comes out with, and it's comprised of many different individual controllers that have all these different versions responsible for you know machine images and authentication and compute and storage and yada yada yada, the GUI, all these things, right? But I think what we saw with OpenShift is, or not OpenShift, but OpenStack, is that it was always, I always saw people struggle with it. Like it was every distribution, uh, and people just struggled with the variety that was there. But nonetheless, it did have some APIs that you could kind of rely on, and so if you built a product targeting the OpenStack APIs and were kind of tried to stay true to just talking to those APIs and not making too many assumptions about vendor specific implementations, then you could actually go pretty far and work across, Mirantis's stack and HP stack and all that kind of thing. And I think the same is true, and maybe even more true for Kubernetes. I think Kubernetes has like done a great job in how they think about APIs, how they think about versioning them, how like clean and consistent they are.
Yeah, totally.
That I have very high confidence that if a vendor says this is Kubernetes 118 under the hood, and they're conformant according to CNCF, and you're using a version of a Confluent operator that works on 118, then it should. I mean, if you like don't have a storage class, you'll have problems. But that's not like a vendor specific problem. That's not like it's not something that like would be Red Hat OpenShift's fault, right? It might be your specific way of doing weird things. So yeah, we work on OpenShift. We work on all the major ones: PKS, AKS, EKS, GKE, Anthos, um, Rancher. But you could probably pick one out of nowhere. We have customers like doing uh, potentially inadvisable things, like building case from source, but it
Uh-oh.
works. Like yeah,
So Brian's got a great question here in the chat. He's
yeah.
asking about if you can talk a bit about scaling metrics and when the operator scales the Kafka cluster and how long the scaling operation typically takes.
Yeah, so scaling is a really interesting question, especially for data services, because you need to not only like run a new instance, but if that instance doesn't have any data on it, then it's kind of useless. It's just sitting there idle. So you actually need to move the data around too. And so this is something that I think we've got a pretty special and pretty unique in the Confluent Kafka operator that that isn't kind of out there in the wild. So with the w- so let's talk about those two pieces. So with the Confluent operator, we're actually we're gonna soon launch kind of the next version of the operator as part of our next major Confluent platform release.
Oh,
Should be
nice.
in a month or so. And in that, and I've already kind of demoed this, so I don't think I'm kind of going over my skis saying this, but
Cool.
you can scale up your brokers pretty instantaneously. You can what we're adding the ability to say, to go from saying like 6 brokers to 20 brokers, let's say, and they'll all come up in parallel. And what I've seen on like my GK environments, they take about 2 to 3 minutes each,
Hmm.
but it's in parallel. So rather than 2 to 3, times 10, it's just 2 to 3 minutes. Um, so
Oh, that's
between like the
sweet.
JVM starting up and then the process of starting up and connecting to Zookeeper and all that kind of thing, uh, it's it's pretty good. I think the dream would be like they're just up, 10 seconds or something like that. But 2 to 3 minutes, I think, is pretty good. Um, and then we've added something to the Confluent sort of Kafka stack called self balancing, where once you have these new brokers, we will actually automatically rebalance the data from your original brokers onto the new ones, and so uh,
Oh, that's interesting.
it kind of does what it says, right? Now, how long that takes is, um, I would say it's tunable, but really, actually, you shouldn't tune it and you shouldn't worry about it. Like it's a complex algorithm that I don't know how it fully works, but it's looking at the like topology of where's the data, and then it's computing a plan of like what's the most efficient way to move data around that um, ensures availability, doesn't put too much network pressure on there, and it'll just keep doing this. So um, it's more it will kind of continually keep the data in an as balanced state as possible.
Oh, that's awesome. Yeah, and I'd love to hear more about this new operator that's coming out. Maybe if we have a bit more time, or we'll have you on next time once it's out and you can show us all the goods. I'm seeing that Alvaro has an awesome question in here, and I was going to ask you something along these lines, but Alvaro put
Yeah.
it a little bit more eloquently than I think I could have. He was saying, what's your take on the programming languages or frameworks to develop operators? Because most operators are written in Go, but an operator is just a normal Kubernetes application and could be
Mm-hmm.
written in any language. We're
Mm-hmm.
developing quite large and complex operator in Java, and we'd like to see more variety in languages to develop operators.
Yeah. I guess what I'll say is I'll put on my like engineering hat. So my my background is in engineering, and now I'm in product.
Uh-huh.
So I always feel a little bit like I shouldn't I shouldn't have an opinion on what languages people use, but I do. Um, the so actually I just kind of for fun I wrote an operator last year. I used the Cube Builder framework, and I know the team at Confluent has recently switched to the latest version of the Cube Builder framework. And I think they were using a either a different framework before, or not using any framework before, and are now using the Cube Builder framework. Um, and so that's all kind of Go based. As far as like what language to use and what framework to use, uh, I guess even though I just said a second ago I do have opinions, I think on this one, like I definitely don't have like a super educated opinion. I would say that like I think Kubernetes is all in Go. The Kubernetes client libraries in Go are probably, better and more rich than the ones in Java. I could be wrong about that. Uh, it's probably going to be better documented and all that kind of stuff. You can see examples in the Kubernetes CLI, for example, using the Go thing. So I think like just that ecosystem will make it easier to use Go. Um, and then as far as what frameworks to use, Cube Builder is Go, gives you a Go, Go scaffolding. So if you use that framework, you're going with Go. Um, but yeah, I mean, I think it's still early in my in my own use of Cube Builder, like a year ago. Maybe this is not a fair comparison, but like I roughly compared it in my head to Rails, to like Ruby on Rails. It's obviously not the same thing,
Hmm.
but they're both like frameworks intended to help developers build a common kind of application. And it just felt like there's a long way to go. Like there's a lot of opportunity still to make these frameworks, Rails like, let's say, right? I mean, Rails was like a phenomenon in its day, and is still kind of used all over the place. I didn't get the feeling that like Cube Builder is like a phenomenon, right? Like it's still got a ways to go to be for every to be like joyfully, there's no Cube Builder conf like there's a Rails conf or anything like that. Maybe there never will be, right? Like Rails is obviously for web apps, and everybody's building web apps, and um, probably not everybody should be building operators. That'd be a good topic in its own right. But like hopefully there's a lot more simple web apps in the world than there are complex operators.
Yeah, well, that is an interesting like theme that we could dive into as like kind of a last question is
Yeah.
when to build your own operator. Why why is it, because I've heard a lot of people say, yeah, I built, like you said, why, for fun I built this operator and it helped me out do X, but then you're not building like a super beefy operator, I imagine. Or was it what you built was something that was
No, it wasn't
heavy lift?
beefy. It was I mean, I really part of it was just to play with the cube builder framework.
Hmm.
Um I just wanted to play with a few different concepts. So it was for my own learning. It wasn't I would not put it in production or anything like that.
Yeah. But then you
Uh
have like Alvaro on this side. He's
yeah.
saying, yeah, I'm about to build a very complex operator.
Yeah.
And so this idea of, okay, when to build your operator and when not to,
Yeah.
when to go out there, because every day there's a new operator that'll spring up. So
Right.
uh, I'd love to hear your thoughts on that.
Yeah. So, like I did a little bit of like look around of some of Confluent's like peer sort of companies. You look at like Mongo, Elastic, Couchbase, Redis. Um, who else did I look at? Like Cockroach, all these different sort of like data products. And I just looked at like how are they offering their self-hosted products, and beyond just like the low level like binaries, what's their solution for like managing the platform? And the most common way there is the operator, right? So it may seem like early days for operators, but I think they're already, if you know, they're already kind of like ubiquitous. Um,
Yeah.
so when to build one, like, so for that kind of class of application, data services, I would say specifically like distributed data services that all tend to have their own bespoke ways of, or idiosyncratic ways of like managing the life cycle, right? Like just write down all the steps and like edge cases and if conditions for rotating certificates with your product, or just upgrading it or applying a patch. Look at how complex that is, and then just ask yourself like, should my customers do this? Should like a human be walking through these steps, or should we encapsulate this in code and ship that to the customer, right? If you just have a stateless web app and like adding a new instance is literally just like add the instance and start it, then you don't need an operator, right? Um, if upgrading it is just you upgrade the image and like roll it out and it will just work, then you probably don't need an operator, right? If it's like well, you got to know which one is the leader, and you got to like orchestrate this sort of dance on everything except the leader, and check for this metric before stopping this thing and starting the new thing. And you got to make sure they're all talking this different protocol version to each other. Um, then yeah, it's more complicated, right? Anytime there's like uh, these sorts of, maybe here's like a key kind of insight here is like, with these data services, they need to know about each other, right? It's not n horizontally scalable independent instances of your application. There's some intercommunication and like cluster level knowledge that is above and beyond the knowledge of the process itself. Maybe like very concrete example is you could have 3 Zookeeper nodes running and none of them are the leader. So they're all running. You might see one/1 in your kubectl get pods, but nobody's the leader. So that cluster is not healthy, right? So those are the kinds of cases where you actually need something outside the cluster that can look at the whole cluster and say, this isn't healthy, something needs to be done. That's what an operator can do,
Uh,
right? If it's just like more of the same thing and they don't need to know about each other, then you don't need something smart sitting outside, like looking at the whole thing and orchestrating things, right? So I think that's like, I don't know if Alvaro. Also, by the way, all these questions have been awesome. This is really great.
yeah, it is. It's
Maybe
really
we
great to
can.
see.
I'm curious to like follow up. Alvaro, like on Slack. What are you building your operator for? Maybe it might be a great idea. It might not be. I think another. So I only gave one kind of example, which is these data services.
Hmm.
I think another use case people have for operators is to give a Kate's native declarative UX in front of some API on the back end so that you can Postgres operator. So like Postgres seems like a great like bread and butter use case, I would say, for an operator.
Yeah.
Um, yeah, but you might also have some like I saw this talk from Google that the Borg team was actually writing a Borg operator. Borg is Borg is like the real Kubernetes, the one that Google didn't give to us, right? Like Borg is its own very rich, complex system, but they wanted to give a Kubernetes native UX to Google developers, so that like, because they're already familiar with it, and so they can run workloads on Borg uh, with their Kate's YAMLs using kubectl CLI and their Kate's GUIs and their Kate's uh,
That
RBAC
makes
and all that
sense.
sort of thing. So I think that's like another kind of use case where it can make sense to build an operator as well.
So last one, maybe a quick lightning one.
Okay.
Uh, Alok was asking how you see Pulsar versus Kafka.
I saw that come up in the chat and I was like, yeah, maybe it'll reach 10 o'clock. And yeah, I think I think it's just a more, complex topic.
We got to do a
Pulsar
whole
is,
nother session on.
that's a whole nother session. Yeah. And I think like you could have hours of that conversation and never even talk about Kubernetes. Right. Like, I think the, and I'm also just not the smartest person to answer those sorts of questions. Um, Pulsar, like Kafka, is another Apache project. Um, they're somewhat similar in that they have like brokers. You have topics, you put messages in and out. They have sort of different feature sets, different performance characteristics, um, different ways that they deal with kind of uh, how like the actual protocol under the hood. As far as like a comparison of the two, I mean, I work at Confluent. I think Kafka is great, and we blog pretty frequently about the reasons why Kafka is great, um, and I think it is. But I'll just be completely honest that like I'm much more new to like the Kafka and Pulsar space than I am to like the Kates and distributed systems
Mm.
in general and like cloud infrastructure space. So I'm happy to point people to like different blogs and stuff like that comparing the two. We just actually launched one I think a couple days ago, if not last week, on Kafka, Pulsar, Rabbit, and kind of comparing the three. Um,
Perfect.
but yeah, I think that's my like simplified takeaway.
Well, you've been a
Kafka's
great
great.
sport. I really
Yeah,
appreciate this. We're at the top of the hour. I am putting
cool,
in
man.
the chat the Slack URL. So if you want to join us in Slack or you want to talk to Amit offline, feel free to reach out. He is on there. He is vocal, sharing his wisdom with us. I really appreciate you all coming and staying till the end and listening. If you want to talk about operators or you know somebody that would be great to talk about operators for session 2 of this series, please reach out and let me know because I think this is just such a deep topic that we could go into. Really, thank you again, Amit. I've had a
Thank
blast.
you so
This
much. Yeah, it's been super fun, and I look forward to the follow on conversation, and also want to learn from the rest of you, like building operators, putting it out there in the field, and
mm,
what are your kind of war stories out there. Yeah, looking forward to
totally.
keep this conversation going.
Yeah,
Thank you
we
so
have a
much.
whole channel for operators in the Slack, so hope to
Yep.
see you all there.